Hello, excuse me. Hello, class. This is Dr. Beloff, and I have a video for you here, a video tutorial to show you in a reasonably straightforward way how to calculate the net present value, internal rate of return, and payback for a project. Now, if you've gone through the textbook and you've seen the lecture, reviewed the lecture for this module, you know there are several ways in which you can do the calculations for net present value. I'm going to show you two. Also keep in mind that you can have, you can use your calculator and use the formulas that are in the book. I'm going to show you two of the easier ways to do it. I don't personally tend to use a calculator. I'm facile enough in Excel and it makes things faster and easier. So I'll show you these two different ways. And then if you want to use your calculator, the formulas are in the book and you can figure that all out. Now, what I've done here in this particular example is given you a shorthanded form of a problem in net present value and rate of return. So we've got basically a capital project you see here, and the initial outflow before the project starts, in other words, before we start earning any money on the project, of $10 million. You can see it right here. This is in year zero. We use year zero as a convention. It simply means that we're going to have to put the money out ahead of generating kind of revenue and ongoing operating expenses for this particular project. Now, I have short-circuited this a little bit in the sense of normally in the questions you see in the textbook, you'll see a revenue number for each year. You'll see an expense number for each year. And the net of those are the cash flows, positive or negative, for a given year. In order to shorten the video here, I've simply given you the net cash flows right here in this area. But again, if you were if you were looking at a textbook problem over here, you might have, revenues for these years and expenses for these years. You would subtract the expenses from revenues and you would get these values that you see here. Now in the second set of columns, I've simply done the cumulative cash flows because I always like to follow that. You see effectively when you do that, you see that in somewhere around year 4, in terms of nominal dollars, this project breaks even. That is to say, it's if you take the initial 10 million and then you start taking these positive cash flow numbers, you see that when you reach sometime in year 4, the project flips to being a positive in cash flow terms. And that allows you, by the way, to calculate the break-even year. Now, I'll talk about that in a second. We're going to go back to that. But we know that from a nominal dollar value and not adjusting for the time value of money, this project starts to turn positive in year 3. Okay, now, what's this all about? Well, you can solve for the net present value by using one of two methods that I'm going to show you here. One is the textbook method, or what I'll call the table method, and then using the Excel function. Personally, I always use both of these when I'm solving a problem, because if you made an error in one of them, it's unlikely you made the same error in both of them. It reduces the chances you'll have a math error, and I'm going to talk you through that in a minute. But you see here that this project, we had assumed a cost of capital of 11%. It's just a given, okay, just like all these numbers are givens. What that means is I'm going to go to the textbook or any other place where I can find a discount table, and I'm going to get the discount factors for a rate of return or a discount factor or a cost of capital. There are different names that you can see of 11% per annum. And what I've done here is I've gone ahead, and if you were to go back to the Zellman text, you see that I've actually extracted those multipliers, those discount factors, right from the textbook. And I've gone right to the book and said, okay, in year 1, at 11%, the factor is this. In year 2, it's this, and so forth. Okay? Of course, in year 0, there is no discount factor for dollars you spend right now or dollars you have right now. So that's a 1.0. Now, the numbers over here, the net present value, as I'm calling it, are simply these these cash flows over here in column F times that number. So if you were to take $2 million, multiply it times that factor, you will get 162320. And in fact, if you look up here, that's the formula. Okay? So I did that with each of these numbers. Right? So each of these numbers are simply the raw cash flows over here, right here, times these discount factors. That gives us our discounted cash flows, right? Discounted each year, as you go out in time. That 11% factor diminishes the present value of the money you're going to get sometime in the future. And that's what we're talking about, net present value. Now, what's the net present value of this particular investment? Well, when you come over here, you'll see that the net present value for this project is 8.819250 is the net present value, okay? In other words, for all of these years, if you were to take these years, and I hope I'm right here when I do this, yes, you'll see you'll get, and I'm going to have to adjust this formula, I just mucked it up. But you can see that and I'll fix that in a second, you can see that this number equals that number. That's the net present value of this project at the end of year 5. Now let me go back here because clearly I messed up this formula when I did that. So I'm gonna now show you how to get the net present value here. This is what we get when we use the formula. This is what we get right here when we use the table. Now you can see they're different, but they're only different by a little bit. All right. So in other words, that's a rounding error. How does that occur? Well, Excel uses more decimal point places than the table in the book does. So it gets a slightly different number, but it's pretty close, as you can see. Now, let me show you how to calculate, now that we have this net present value over here, we'll just put this number in, we'll put it in that color. Question is, how do we get that number from the formula? So let's try it, and I can show you how it's done. So we go up here to formulas, and we go to financial formulas right here. And we come down here to net present value. Now, you'll see the template pops up. Now, the rate is pretty obvious here. It's 0.11. That's they're asking effectively, the Excel is saying, what is the cost of capital or the discounting factor you want me to use? We're using 11%, which is, of course, the same as that. I changed that by mistake. But it's the same as we have over here. Now it says, tell me the sequential values of this array of cash flows. Now notice our yearly cash flows are over here, our net ones. And this formula, because it's set up in a particular way, we can't put year 0 in there. This is just the way Excel decided to do the formula. So we're just going to do this. You see, as I do that, these values, these cell values, if you will, automatically compute. So watch this. We're going to get a number over here. Now you say, well, there's something wrong, and there is. Why? Well, this formula is presented the net present value of only the cash flows from year 1 through 5. So what we have to do is go up here and subtract the initial investment. In this case, it was $10 million. When we do that, we do in fact get this number. Okay, I'm going to go back here, and I'm going to just get rid of the pennies. So you can see this is how you solve for net present value using the formula, and you'll see that this is within, I don't know, a couple of bucks, looks like. Let's see here. I'll just cut this, put it up here, and you can see that we're almost identical there, $500, something like that. Now, if you were doing this on the exam, you could show me both numbers, both would be accepted. If you only showed me one number, I'd probably accept that anyway. That is to say, if you did it only one way and you gave me that number and I had already calculated both, then I would also give you full credit for that. So that's how you use you calculate net present value of a project using both the discounted factors in the table over here and the net present value function in Excel. And of course, the payback accumulator, here you just simply look and say, oh, okay, this project as we moved along on a discounted cash basis was still negative in year 3. But when we add the discounted cash flow for year 4, you see that we flip to a positive number. Ergo, the payback period or the payback year is year 4, sometime in year 4. We don't know. We're not trying to calculate any more finely than that. Now, the last thing we're going to do is we're going to show you how to calculate internal rate of return. There are a couple of ways to calculate internal rate of return. There is a formula. It's in the book. I never use it. I always use the Excel formula, and because it's so darn easy. Now, let me show you how this is calculated. I've already done it at 31.3%, but let me go get the formula up here. Again, we go to formulas, we go to financial, and we come down here to IRR, internal rate of return. Now, you'll notice here that it's asking for both values and a guess. Now, the values themselves, effectively what IRR is saying is, give me the cash flow values for the successive years and I will return the internal rate of return. Keep in mind here that it's important you keep this in mind. These are the undiscounted cash flow values, and in this case, they do include the negative value in the first year. Why did they do it that way? I don't know. In any event, all you have to do is highlight those numbers. Now, here's the second thing. They'll ask you for a guess. I've never used the guess. In theory, the guess helps this number become more accurate. I don't know. This is kind of good enough for me. And I've never really putzed around with this idea of what's the logic behind a guess. You'll notice here, by the way, that the formula is already giving you the answer over here. 3.31344, et cetera, et cetera. I'm going to hit OK. Well, I should have done that in a separate box. Let me go back. Sorry. Let me go over here and do it. So I'm going to do that one more time. I'm going to go up here, get my internal rate of return template, and then I'm going to use these values right here, and that should give me the number, and it does. You see now, it's not the same because I have not changed the number of decimal places, if you will. So in any event, this is the way that you can use the Excel functions and the table in the book to calculate net present value of a project, the payback in years, and the internal rate of return. Now, if this video doesn't do it for you, then clearly you should use the Ask the Professor forum, and we should be all set. I'll be happy to walk you through enough examples to make this make sense for you. Thanks so much, and I hope you enjoyed this. Thank you.